Hello everyone, welcome to Project Infinity. Today we are going to discuss JEE main previous year questions from work, power, energy. So let's get started. So let us start with our first question. It says the bob of a pendulum was released from a horizontal position. The length of the pendulum is 10 meter. If it dissipates 10% of its initial energy against a resistance, the speed with which the bob arrives at the lowest point is. So we need to find the speed. So let us draw the situation. Here is the bob of the pendulum in this position. This is our bob. It is tied to this fixed point and it will come below over this position. So I can say that this is our initial position, the horizontal position, and vertically is the final position. So in order to find the speed, what we will use is, let us first take, this is the height h. It has fallen down and this height h is only the radius or the length of the pendulum, 10 meter. Now I will use energy conservation in order to find the speed. So energy conservation between the initial and the final positions, and it is given that it dissipates 10% of its initial energy, which means 90% of energy is left. So I will use the equation directly and write it as 90% of mgh, which is 90% of potential energy converted into kinetic energy, half mv square. So 90 by 100 into g was 10 and height is also 10. This is half v square. So ultimately cancelling out the terms, I will get v square equals to 180. So v is simply under root 180 and 180 can be written as under root 36 into 5, which is 6 root 5. Unit is meter per second. So I will get option 1, 6 root 5 meter per second as our final answer. So this is the answer to this question. So in the next question it says two bodies of mass 4 gram and 25 gram are moving with equal kinetic energies. We need to find the ratio of magnitude of their linear momentum. So kinetic energy K equals to half mv square. We know this. And also we know linear momentum P equals to mv. So I can say P square, this is equals to m square v square. Now from two equations I can say K equals to P square by 2m. This can be remembered as a direct relation. So from here I can say P equals to under root 2mk. So we need to find the ratio. So I can say that P1 by P2, this is equals to under root m1 by m2, because kinetic energy is equal. So only depends on the ratio of m1 and m2. So P1 is to P2 equals to under root, the first mass was 4 grams, so under root 4 is to under root 25. Both are in grams, so I have not converted the units. So 4 and 25 we get 2:5. So option 3, 2:5 is the correct answer to this question. So here is the next question. It says a bob of mass m is suspended by a light string of length L. It is imparted a minimum horizontal velocity at the lowest point A such that it completes half circle reaching the topmost position B. We need to find the ratio of kinetic energies KEA is to KEB. And it is given minimum horizontal velocity at the lowest point A such that it completes half circle reaching the topmost position B. This implies that the lowest velocity VL, this is under root 5GL. We should remember these relations. All this comes from energy conservation. Now we need to find VH, which is the velocity at the uppermost point. So we will use energy conservation. So energy conservation at the lowest point and at the upward point A and B. So gain in potential energy PE, this is equals to loss in kinetic energy Ke. So what is the gain in potential energy? It is mg and 2 times L. Mg 2L, this is equals to half m v lowest VL square minus half m VH square. Now from here I am cancelling out m. So we are getting from here 2 times GL, this is equals to half VL square is 5GL minus half VH square. So if I take half from this side, I am getting 4. So ultimately I will get VH square, this is equals to 5GL minus 4GL, which is GL. So our VH is VH, this is equals to under root GL. This is also an important relation. Now we need to find the ratio of kinetic energies. Now we know that kinetic energy Ke, this is equals to half mv square. So Kea by Keb, m is constant. I am writing it down, half mv L square by half m v h square. Half m is constant, so it is cancelled. VL by VH whole square. So I will get 5GL divided by GL. GL gets cancelled and I will end up with 5:1. So 5:1 is our final answer. Option 2, I can see 5:1. The ratio of kinetic energy is A times B. We need to see this carefully. So option 2 is the final answer to this question. So next question is, a ball of mass 0.5 kg is attached to a string of length 50 cm. The ball is rotated on a horizontal circular path about its vertical axis. The maximum tension that the string can bear is 400 Newton. The maximum possible value of angular velocity. So we need angular velocity, which is omega. So first of all, we need a horizontal circular path. So let this be the horizontal circular path. And the ball is rotated on this path. So this is the ball, and let this be the string connected to its center, and in this direction centripetal force is acting, Fc, and this is also the direction where T max, the tension, maximum tension which we need, 400 Newton, which is given, this is T max. Therefore I can say T max, tension max, is equals to the centripetal force. The tension provides the necessary centripetal force, which is equals to m omega square r. From here I can say that omega square equals to T max divided by mr. So ultimately I will get omega, the angular velocity, equals to T max by mr under root. So this is inside under root. Now putting the values which we are given in the question, T max is 400 Newton, so 400. Mass is given as 0.5 kg, so 0.5. Radius is given as 50 centimeter, so 50, and I need to convert it into meter, so into 100 above, 50 by 100. So this turns out to be 400 divided by 5 and 10 above, and from 50 and 100 we get 2. So ultimately we get 40 from the under root. So 40 radians per second is our final answer. So option 2, 40, is the correct answer to this question. So the next question says, a block of mass 100 kg slides over a distance of 10 meter on a horizontal surface. The coefficient of friction between the surfaces is 0.4. Then the work done against friction. So let us draw this. This is our path. Let this be the block of 100 kg. Now this will slide over this path. And let us take this distance as 10 meter, the distance. So mg is acting downwards, 100g, and the normal reaction force N is upward. So I can say that frictional force is mu n. Here n is mg, so mu mg. This is our frictional force. Now we need to calculate work done. So work done by frictional force, the magnitude of this frictional force, because we have given that work done against friction. This is equals to frictional force into the displacement. So I can write mu mg x. So from here, substituting the values, mu is given 0.4, so 0.4, mass is 100 kg into 100, g is 10 and x is 10 meter. So this turns out to be 4000 joules. So 4000 joules is the correct answer to this question. Moving on to the next question, it says a body of mass 2 kg begins to move under the action of a time dependent force given by, the force is given as 6t I cap plus 6t square j cap. The power developed by the force at the time t is given by, so we need to find the power developed. Given, we are given force vector as, and we know force vector is mass into acceleration vector. This is given as 6t I cap plus 6t square j cap. I need to place the j cap in the question, it has been missed. So acceleration vector a, and I am dividing with 2 kg mass is given as 2 kg m. So I will get a vector equals to 3t I cap plus 3t square j cap. From here I can say that, and I know acceleration is dv by dt. So from here I will write dv vector equals to 3t I cap plus 3t square j cap dt. I will integrate both sides and I will find out the v vector. So v vector, this is equals to 3t square by 2 I cap plus 3t cube by 3 j cap. Now I have got the v vector, which is ultimately 3t square by 2 I cap plus t cube j cap. Now we need to find the power developed. So we know power is equals to F dot V. This is an important relation and we will make use of this. So power vector P, this is equals to, force vector was given as 6t I cap plus 6t square j cap, dot product with v vector, which we found out 3t square by 2 I cap plus t cube j cap. Now the dot product will result 6 into 3 by 2 t to the power 3 plus 6 t5. So ultimately I will get 9t cube plus 6t5, and this is in watt. Unit of power is watt. So going to the options, I can see option 4 is 9t cube plus 6t5. So this is the right answer to this question. Now this question says a stone of mass 900 gram is tied to a string and moved in a vertical circle of radius 1 meter. So 900 gram 1 meter and making 10 rotations per minute. These are the important things we are given in the question. We need to find the tension in the string when the stone is at the lowest point. So given in the question, omega is 10 rotations per minute, 10 rpm. This is equals to 10 into 2 pi by 60. We multiplied this in order to convert the rotations per minute into radians per second. So this turns out to be pi by 3 radians per second. Now we need to find the tension at the lowest point. So let us draw this. This is the stone tied to the string and it will move in this direction with this omega. These are the extreme positions. Now at the lowest position, let us draw the FBD. Here mg will be acting in this direction and above it is tension T. So I can say that F net will provide the necessary centripetal force. So F net equals to Fc. and F net is tension T minus mg. This is equals to Fc, and Fc is m omega square r. So tension T equals to mg plus m omega square r. So we need to find this tension by putting the appropriate values. Therefore I can say tension T equals to, now putting the values, mass is 900 grams, so 900 by 1000 in kgs into 9.8, because in the question we are already given G is 9.8 meter per second square, plus mass is again 900 grams, 900 by 1000, and omega square, omega was pi by 3, so pi square by 9, and radius which is 1 meter. Now simplifying it further, 0.9 into 9.8 plus 0.9 into 9.8 by 9. I did this because pi square, this is also given in the question as 9.8. So further simplification, 0.9 into 9.8, I have taken common, so 1 plus 1 by 9. So ultimately I will get 9 by 10, 0.9, and into 9.8, and in the bracket I am getting 10 by 9. So 9 and 9 and 10 gets cancelled. We are left with 9.8 Newton. So this is our final answer. So the tension in the string is option number 2, 9.8 Newton. The next question says, the potential energy function in joule of a particle in a region of space is given as U equals to 2x square plus 3y cube plus 2z. Here x, y and z are in meters. The magnitude of the x component of force acting on the particle at point P 1, 2, 3. So what is asked is magnitude of Fx, x component of force, at the point P 1, 2, 3. These are the coordinates given. So we know that Fx equals to minus du by dx. Only we need to differentiate with respect to x. So minus d, and in the bracket we have to take 2x square plus 3y cube plus 2z dx. Now we need to differentiate only the x function. So I will get minus 4x, because y cube, z all are constants and these will yield 0. So Fx at the point I will get is minus 4x, and magnitude wise only 4x. So therefore Fx at point 1, 2, 3, so x is 1. This is equals to 4 into 1, which is 4 Newton. So the correct answer is option 3, 4. Now the next question is a very beautiful question. It says a ball suspended by a thread swings in a vertical plane so that its magnitude of acceleration in the extreme position and lowest position are equal. So this is the relation we are given. We need to find the angle of thread deflection in the extreme position. So let us draw this. Now this is the thread. A ball is suspended and it swings in a vertical plane, and this is the extreme position. So let this be the extreme position. And in this extreme position, I can say that the acceleration, the tangential acceleration, is g sine theta. Definitely we know how to convert, and this is the theta. And at the extreme position, definitely velocity is 0, lowest position v max, v in this direction, and the acceleration is centripetal one, so this is v square by r. And I have taken the length of the string to be r, and g sine theta was the tangential acceleration. Now let us take that the ball drops from this position and this height be h. Now using plane geometry, I can say that our h height, this is equals to r minus r cos theta. We know how to break in components, so I take r common, r 1 minus cos theta. This is our height drop. Now in order to calculate the velocity v, what I will use is, I will take use of energy conservation. What I will do is, let this be the initial position, the extreme position, and then finally it falls to this lowest position. Now I will use energy conservation between these two positions. So energy conserve. So loss in PE will be gain in kinetic energy. So mgh equals to half mv square. So m will get cancelled. I can write 2gh, m will get cancelled. So this is equals to v square. So this implies v square equals to 2g, and h I am substituting r1 minus cos theta. So ultimately I will get v square by r. This is equals to 2g 1 minus cos theta. So I found v square by r, which was our centripetal acceleration, and in the question we are given that acceleration magnitude in the extreme position and lowest position are equal. So our g sine theta, the tangential one, this is equals to centripetal one, which is 2g 1 minus cos theta. So I will write an important relation over here. The relation is, we know cos 2 theta, this is nothing but 1 minus 2 sine square theta. I will only use the half angle formula of this, which is cos theta equals to 1 minus 2 sine square theta by 2. I will make use of this relation and simplify the above equation. So for sine theta I will use 2 sine theta by 2 cos theta by 2. So ultimately I will get 2g sine theta by 2 cos theta by 2. This is equals to 2g, and 1 minus cos theta is 2 sine square theta by 2. Now from both sides I can cancel out 1 sine theta by 2 term, and 2g also gets cancelled. Ultimately I am left with cos theta by 2 equals to 2 sine theta by 2. So further I can say tan theta by 2, this is equals to half. So we need our angle deflection theta, which is theta equals to 2 tan inverse half. So 2 tan inverse 1 by 2, this is our deflection angle, and we need to find this angle. So going back to the options, I can see that option 2, 2 tan inverse 1 by 2, this is the correct answer to this question. Now here is the next question. It says a block of mass 1 kg is pushed by a surface inclined to a horizontal at an angle 60 degree by a force of 10 Newton parallel to the inclined surface as shown in figure. When the block is pushed up by 10 meter along the inclined surface, the work done against frictional force is. So I need to find the work done against frictional force. Work done, this is equals to the dot product of force and the displacement. This is the basic definition of work. So work done by frictional force is equals to force of frictional force into displacement x. Now what is force of frictional force? Frictional force equals to mu times n, and here n is mg. So mu mg, this is the frictional force. Now the work done will be mu mgx, and for dot product cos theta, angle between displacement and force vector. So putting the values, we are given mu is 0.1, so 0.1, mass is 1 kg, g is given as 10 meter per second square, and x is also 10 meter, and cos of 60 degrees is half, so half. Now cancelling the terms, I am only left with 5. So 5 joule is the final answer. So the work done is equals to 5 joule, option 2. Moving on to the next question, it says a particle is moving in a circle of radius 50 centimeter in such a way that at any instant the normal and tangential components of its acceleration are equal. If its speed at t equals to 0 is 4 meter per second, t equals to 0, 4 meter per second is given. The time taken to complete the first revolution will be, we are given a format, and in this format we need to find what is alpha. So basically what we are given is, at that instant normal and tangential components are equal. So AC is equals to A tangential. C is centripetal or the normal acceleration. So the normal acceleration AC is equals to tangential. And we know normal acceleration V square by R. So V square by R equals to V dV by ds. So V gets cancelled from both sides. We are left with ds by R equals to dV by V. We will integrate both sides. Now after integration, and let us put the limits also. We are given that t equals to 0, 4 meter per second. So 0, and on the V side I am writing 4, and up to V, and distance s. So after integrating I will get s by r equals to ln of V, and ln of V is from V to 4. So we will get s by r, this is ln of V minus ln of 4, or I can say ln of V by 4. Now if I replace ln, I can say that V by 4 equals to E times S by R, or from here I can say that V equals to 4E S by R. Now we have found an important relation. I will make use of this. So we know, I can say V equals to ds by dt. Definitely velocity is ds by dt. So using the relation I have got for V, I will write ds by dt, this is equals to 4E S by R. Now ds equals to 4E S by R. Let me replace E S by R on the other side. So 4 dt, and here at the denominator E S by R. Now we need to integrate this. So E minus S by R ds integration. Now we need to place the limits. For complete first revolution, S will be 2 pi R. So 0 to 2 pi R integration. And on the right hand side, integration from 0 to time period t 4 dt. Now integrating, I will get on the left hand side minus r e to the power s by r, and I need to place the limits 0 and 2 pi r. This is equals to 4t from the right hand side. So putting the values, I will get minus r e to the power, and for s I will put 2 pi r. So I will get minus 2 pi r by r minus e to the power 0 is 1. This is equals to 4t, capital T time period. Now this is equals to r 1 minus e to the power minus 2 pi. This is equals to 4t. Now I am getting the relation of time period. Therefore t equals to r by 4 1 minus e to the power minus 2 pi. Now if you observe carefully, I have got this relation, and this is similar to that asked in the question. So equating these two, I will find out alpha. So from our relation I can say, thus 1 by alpha equals to r by 4. And in the question I can see that r is given radius 50 centimeter. So r is given 50 centimeter. So converting it into meter, I will get r equals to 50 by 100. This is equals to half meter. So I am using this. 1 by alpha equals to 1 by 2, and 4 is already in the denominator, 1 by 8. So from this comparing, I can say that alpha equals to 8. So we needed alpha. So the value of alpha is 8 in this question. So 8 is the correct answer to this question. Now let us move on to the next question. It says, a coin is placed on a disc. The coefficient of friction between the coin and the disc is mu. If the distance of the coin from the center of the disc is r, the maximum angular velocity which can be given to the disc so that the coin does not slip away is. So we need to find maximum angular velocity or omega max such that the coin does not slip away. So let us draw this. This is our disc moving along this axis with omega, and let us draw the coin over here. This is the coin and its distance from the center is r. So we know that the centripetal force is m omega square r, and friction is acting in this direction, and the centripetal force is being provided definitely by the friction. So I can say that frictional force, this is nothing but m omega square r. In order to find omega max, I need to find the maximum frictional force, which is mu mg. This is equals to m omega square maximum times r. M gets cancelled from both sides, so omega square maximum, this is equals to mu g by r. So ultimately I will get, therefore omega max, maximum angular velocity, equals to mu g by r, and inside the root. So this is maximum angular velocity, and I think this is option number 3, root mu g by r. So this is the right answer to this question. Moving on to the next question, we are given a particle is placed at a point A of a frictionless track ABC as shown in the figure. It is gently pushed towards the right. The speed of the particle when it reaches the point B. So VB we need to find out. Let me draw this with a different color. Okay. So initially we are given that VA equals to 0 because the particle is placed at point A without any velocity, just placed. So VA is 0. We need VB. I will definitely use energy conservation. So I will write loss in potential energy, loss in P equals to gain in kinetic energy KE, to find the speed of this particle at point B. Now mgh, this is the height lost, equals to half mv square, the gain in kinetic energy, and vb square it is. Now what is height h? This one is the height h, and this height h is equals to 0.5 meter because 1 meter minus 0.5 meter. So m gets cancelled. I am left with 2gh equals to vb square. So ultimately I am getting vb, this is equals to under root 2gh, and putting the values I will get 2 into g is given as 10 meter per second square. So 10 into h is 0.5, so 1 by 2. So I am ultimately left with root 10 meter per second. So option 2, root 10 meter per second is the correct answer, and this is the velocity at point B. So this was a very simple question. So we have completed discussing all January attempt questions from work, power, energy. I hope you like the content. This is the fastest way to complete your PYQs. Make sure to hit the like button and subscribe to this channel in order to get more quality content. Thank you.